Next, let's talk about the hierarchical network design. Um, with networking, hierarchical design involves dividing our network into layers so that it's easier to uh, divide things up, get things to work properly. Helps the network designer and the architect to optimize and to select what the hardware is that you need. It also makes your computer and your network run smoother if things are laid out properly. The hierarchical design is going to apply to both LANs and WAN designs. You'll use it across the board. Typically, with the enterprise LAN, you're going to have three distinct layers, and those are your access layer, and that provides a work group or user access to the network. You have your distribution layer that provides the policy based connectivity and controls the boundary between the access and the core layer. And then you have your core layer, and that provides the fast transport between your distribution switches within the enterprise campus. And another benefit for dividing the flat network into smaller, more manageable pieces is with network traffic. If things aren't needing to go outside the network, then it's not being diverted in that area to see if it needs to go out. It's maintaining everything inside that needs to stay inside. And as your layer 2 devices don't have a lot of opportunity to control broadcast or to filter undesirable traffic, sometimes that can get bogged down. So if you have things broken out into a layer, you tend to have better networking speed and better network functionality. Now keep in mind that there is no absolute rules for the way a campus network is physically built. While it's true many campus networks are constructed using three physical tiers of switches, that's just not a strict requirement, okay? So just because you see it here as a suggestion doesn't mean that it's written in stone. Okay, so here I'm going to click play and you'll see how our flat switch network becomes a hierarchical network. You'll see here we've broken them down. Back up just a little bit. Here's our flat network. We've got our routers here, our switches here. We've got our PCs. As we go through here, we're going to divide things up. We have each section here. Now you see that we've put in layer 3 switches and we're beginning to divide it out. And here we have our core layer, our distribution layer, and then our access layer. You can also see how if we have multiple buildings, each multiple building may also have your access, your distribution, and your core. Okay, so it's not a given. Here's another example of a hierarchical design in a LAN environment. The access layer is going to grant end devices access to the network. And then in the WAN environment, it may provide teleworkers or remote sites access to a corporate network across the WAN connections. And here in this example is the access layer for a small business network. It generally incorporates the layer 2 switches and access points providing connectivity between workstations and servers. Okay, and the access layer serves a number of functions, including our layer 2 switches, our high availability, our port security, quality of service classifications and marketing, and trust boundaries. We have our address resolution protocol, or ARP. You remember that. We also have VLAN access control list, our spanning trees, and our power over Ethernet, as any of our auxiliary VLANs and voice over IP. Next, we're moving up to the distribution layer, and that's going to aggregate the data that it receives from the access layer switches before it's transmitted to the core layer. It's going to do what it needs to do there. It's going to figure out where things need to go. The distribution layer is the boundary between the layer 2 domains and the layer 3 routed network. Here at this point, we have aggregation of LANs and WAN links. You have your policy based security in the form of your access control list. You worked a little bit with that last time. And filtering, routing services between LANs and WANs. This is when we get into our EIGRP to OSPF. We have redundancy and load balancing at this point, and a boundary for route aggregation and summarizations configured on interfaces toward the core layer. So it's looking toward the core layer, it's just not there yet. And then the broadcast domain control. Because remember, routers or multi-layer switches do not forward broadcast. So the device acts as the demarcation point between the broadcast domains. Now we're up to the core layer, and the core is referred to as the network backbone. The core layer consists of high-speed network devices such as the Cisco Catalyst 6500 or 6800. They're designed to switch packets as fast as possible and interconnect multiple campus components. So they're very robust. Some of the considerations at the core layer include providing high-speed switching, providing reliability and fault tolerance, scaling by using faster and not more equipment, and then avoiding CPU intensive packet manipulation caused by security, inspection, quality of service classification, and other processes. Remember, that is going on at the distribution layer. A smaller business or smaller network may not have all three tiers. It may have a collapsed two-tier system in which the core and the distribution layers are collapsed into one layer, kind of a larger layer. And the collapsed core is when the distribution layer and the core layer function are implemented by a single device. So it's not working across multiple devices to do the core and the distribution. It's just that singular device. Make sure that you take the time to do these activities. This one in particular is identify the hierarchical network design characteristics. This will help you get a grasp on it. It will help reinforce what you're learning in this unit.